Jordan's Lemma Assignment 2. Example, prove that integration from 0 to infinity on x sin x over x square plus a square dx is equal to pi by 2 e the power negative a, where a is strictly positive. Now here m is equal to 1, because whenever we are having an integration, sine of mx or cos of mx, but here it is simply sine of x. That means here m is equal to 1. So we will integrate fz is equal to, we always take e the power iota mz. So here m is 1. So I am taking this as e the power iota. M is 1, so it is iota z. Simple. Okay. Over z square plus a square. Now this is the function which I have to integrate along this contour C. And C is the contour consisting of these real x's from negative r to positive r, and followed by this tau semicircle from positive r to negative r in the upper half plane. Now to find out the poles, clearly fz has simple poles because I'm having in the denominator there is no power. So I'm having the simple poles at z is equal to, just put this is equal to 0 the denominator, and you get z is equal to plus minus a iota. So I'm having the poles as z is equal to plus minus a iota, of which z equal to, which pole lie inside the contour? Yes, a iota lie inside the contour. Now for finding the residue of fz at ai, I'm using the short trick method, which is z e the power iota z, just write the numerator as it is, over derivative of this denominator with respect to z. This is the formula for the short trick at z equal to a iota. So this will become, yes, just put a equal to z equal to a iota over here. It is a iota e the power negative a, because iota will be minus 1, over what is the derivative? It is 2z. So this will be 2a iota, and the residue will be e the power negative a over 2. Simple. Alright. Now using the Cauchy residue theorem over here, so it is integration over c fz dz equal to 2 pi iota times the sum of the residues. But here I'm having only one residue. So this is e the power negative a by 2. Now splitting up this contour C into 2 along the real axis and also along the tau, the semicircle. So this is equal to, let me mark this equation as 1. Now since z over z square plus a square, this is tending to 0 as z tends to infinity, and z over z square plus a square is a meromorphic function, right, in the upper half plane. So by Jordan's lemma, I can say that this integration for limit r tends to infinity is completely 0. So here I'm writing this as negative r to positive r. This will be e the power iota x into x over x square plus a square dx, plus this will be tau, and this will be z e the power iota z over z square plus a square dz, and this is equal to pi iota e the power negative z. Sorry, this is a. I'm very sorry. This is a. So sorry, this is a. Thank you so much. Alright, now the second integral is 0, right? So now, because when this is 0, if I'm having limit r tends to infinity, so I have to take r tends to infinity in this equation, right? Let me mark this as 1. So letting r tends to infinity in 1, so this will be negative infinity to positive x e the power iota x over x square plus a square dx is equal to pi iota e the power minus a. Now I have to change this e the power iota x into sine of x plus iota cos of, cos of x plus iota sine of x, right? So this is x cos x plus iota sine x over x square plus a square dx equal to pi iota e the power negative a. Now you have to remember that in the given integration, I'm having sine of x. So I have to equate with respect to real parts or imaginary part. Because I need sine x, so I have to equate the imaginary part, right? So equating the imaginary part, we get minus infinity to positive infinity. This is x sine of x over x square plus a square dx is equal to, now on the right hand side also I'm having this as imaginary part, I'm having iota over here. So this is pi e the power minus a, right? So this is 0 to infinity twice because it is an even function, because I'm having x also here, and sine of x, this is odd function, this is odd function, but when we change this fx to f of negative x as function, these two will be same. See, if f of x is equal to f of negative x, then the function is e1, and this is completely even function. So this is 0 to infinity twice x sine of x over x square plus a square dx. This is equal to pi e the power minus a, and then 2 will be go to the other side. So this is 0 to infinity x sine of x over x square plus a square dx is equal to pi by 2 into e the power negative a. Here ends up the proof. Thank you so much for watching this video. Do like and subscribe for latest videos. God bless you. Have a nice day. Thank you.